Hi everyone, my name is Rohan. I'm from Cosmos DB. I'm here with my colleagues Ram and Sri, and we're here to talk about real-time analytics with Apache Spark and Azure Cosmos DB. Now, I know it's been a very exciting 3 days for you. You're probably overwhelmed. There's so many things going around, so many announcements. Totally understand that, and we really appreciate you coming out here. Rest assured, we have saved the best for the last, so do not worry, you're in safe hands. And we're going to talk about a lot of exciting stuff. There's going to be a lot of learning in this session as well. And speaking of learning, we have designed this session around a few objectives that I'd like to briefly discuss. Number one, we want you to be comfortable walking out of here understanding why and when to use Cosmos DB in conjunction with Spark. Along with that, the use cases where it's conducive to use Spark in conjunction with Cosmos DB. Second, we're going to walk you through every single line of code that it takes to implement a real-time analytics solution with Apache Spark and Cosmos DB. It's very simple to understand, and I'm sure you can code up the entire thing after the session as well. Third, we're going to talk about a real production scenario that one of our customers, Coca Cola, has implemented and their journey in overcoming real-time analytical problems using Cosmos DB and Spark. They've implemented this solution over the last few months, and they're super happy with it. We'll get into the details of that later. Last but not least, I'm sure you've heard about the new features that we've announced that build on Cosmos DB. Even if you haven't attended Scott Guthrie's or Rohan Kumar's keynote, it's still totally fine. We're still going to talk about the features that we've introduced, which is operational analytics, which is essentially native Spark support inside Cosmos DB, which can enable a lot of use cases, especially with real-time analytics scenarios. We'll get into demos, we'll talk about the benefits of that, and what value proposition that brings for customers and businesses. Now, having said all of that, let's move on to a simple question. Why should we use Azure, Cosmos DB, and Spark together? If you think about it, Spark is the go-to analytical solution that has been deemed as the perfect fit for real-time analytical scenarios in the world. Spark came about in 2014-ish, which is when the first stable release was, I believe. And back then, I was working as a developer at one of the oldest banks in the world, developing fraud detection systems. And Spark was a new thing back then. And the first time I tried it, it's amazing. It's blazing fast. It helps you compute your big data essentially in a very seamless manner. And you can do n number of things with it, right? It makes it so simple. There's streaming, there's machine learning libraries, and whatnot. On the other hand, you've got Cosmos DB in this picture, which is nothing but a NoSQL database on the cloud that is offered on Azure. Now, the benefits of Cosmos DB, a long list, but to sum it up in one sentence, we offer global distribution, low latency SLAs, we allow scaling your throughput in and out at whatever time you need to scale in and out. And it's super flexible. Any change that you make to the throughput is instantly reflected. Last but not least, we have multi-model capabilities. And what that means is if you come from a structured background or unstructured background, doesn't matter. We have options for both of those scenarios. We've got SQL API and Gremlin API for applications that are greenfield or migrating from existing relational workloads. On the other hand, we also have migration APIs for customers that have been using NoSQL databases presently on on-prem or IaaS solutions, like Cassandra, MongoDB, what have you. There's APIs for every single scenario that you could think of. Now, Cosmos DB offers a lot of things, and this sort of presentation caters to the scenario of HTAP. People have often thought of this distinction between databases and analytical databases. There's OLAP versus OLTP. Now, over the time, you might have seen that this line is blurring. OLAP and OLTP are coming together more than ever before. It's all converging now. And databases like Cosmos DB are essentially capitalizing on the principle of HTAP, which is hybrid transactional and analytical processing. This is where you have a layer operational data sits on. At the same time, since storage is now available, and with Cosmos DB, storage is not your primary concern, because most of the build that you pay for is your throughput, which is very sensitive, especially in low latency scenarios. And Cosmos DB enables all these scenarios that satisfy the requirements of low latency and stuff like that. I'm not going to get into detail because this session is more about real-time analytics that is enabled through Cosmos DB and Spark. So we're just gonna stick to this scenario. Now, if you look at all the realms of the industry, there's a lot of use cases that can be used with Cosmos DB and Spark in conjunction, right? There's people from finance, retail, gaming, healthcare, IoT, weather, logistics, aviation, all sorts of industries that are using Cosmos DB to put their data in and use it in real time. We're going to take a few examples of these, and I'll discuss whatever we've seen customers use. Some primary ones, of course, because I don't want to spend too much time on that. We want to spend as much time as we can on demos and the stuff that you can actually take back and implement yourself. Now, a 5,000-foot view. How does real-time analytics work with Apache Spark and Cosmos DB? Like I said, all these industries are dumping their data into Cosmos DB, and the basic question that you would want to ask people, any sort of Fortune 500 CEO or data scientist or engineer, all the way to business analysts or product managers, the simple question that everyone's asking is, what can we do with this rich big data set that we have in Cosmos DB? What's the value proposition that we can derive out of this rich data that we have in this database that is highly accessible and available at a very low latency aspect? And the answer is, the possibilities are endless. Once you have the right data and you have the right compute framework, there's so many things you can implement. A good example, I'm actually going to discuss the use cases that we've seen in all of these industries in a few. But the way that it works is the architecture flow is basically all this data is ingested and stored in Cosmos DB. And Cosmos DB is a very latency efficient database. So it keeps into account your latency needs, and you can, of course, customize that as per your needs. Once this data is stored inside Cosmos DB, there's a really useful, a very handy and nifty feature of Cosmos DB called as a change feed. And to simply define what change feed is, it's nothing but a backend commit log on top of Cosmos DB that shows you what data is changing in Cosmos DB in real time. So if you actually wanted to see what's happening in your Cosmos DB account in real time, this comes out of the box. You can see whatever's happening in real time with change feed. And with this rich stream of changing data using change feed, you can source all these events to Spark with Spark streaming. And then once the data lands in Spark, there's n number of things you can do with it. You can have machine learning, you can have prescriptive analytics, descriptive analytics, and what have you, the whole 9 yards. From there, you can do a couple of things. If you just want to store views, materialized views, or just small views that you want to have for pre-computed batches, you can do that and dump that back into Spark. Or if you strictly want to satisfy your analytical requirements, you can serve those and enable your businesses to make key decisions based on the information that's coming into your database in real time. Now, before I move on, two things that we're going to be talking about in this session: the basic classification of real-time analytical processing architectures. Two things that this industry has seen is Kappa architecture and Lambda architecture. And I'll talk a bit about what these two are. Kappa is nothing but where you have real-time streams, one or more streams ingesting or putting in data inside your compute framework, which could be Spark or anything else. Now, in Kappa architecture, it seems pretty simple because you just have streams and you're processing something in the compute layer, and then you output something which might just enable a business to make key decisions, or might just be information or analysis of your data as it's coming in. But over time, what you would see is that most Kappa architectures turn into something called as Lambda architecture. And Lambda architecture is nothing but you have your streams in conjunction with your batch historical data, and they both come together to supplement or even sometimes complement each other to help the businesses or consumers make more informed decisions. I'll talk a bit more about that as we delve into the low-level details. Now, the basic use cases that we see in the industry among the Cosmos DB customers are retail. A very classic example, you have all the consumer behavior data, you have the customer transactions, you have the customer profile. Customer profile is something that doesn't change a lot. It's relatively static data because someone's age is only going to change once a year. Someone's name is probably never going to change. So it's very static data. But on the other hand, in this batch view, you also have customer transactions. You're seeing what they're buying. Using that, you can predict something and recommend products to them based on whatever retail subsector you're in. Now, if you have real-time data coming in with transactions, if someone's buying something, and that transaction has parameters like, oh, this person's in Seattle or in downtown, why don't we send them a product recommendation for nearby stores, and they might be interested in buying something since they're already shopping, right? You can use such use cases as a classic example for retail real-time analytical processing scenarios. Spark and Cosmos DB work together to enable such use cases. Finance, another classic example. you have banking transaction data that defines a consumer or a customer's behavior from the last 10, 15, 20 years, however long you've been storing customers' data for. And with that data, with that rich data set, you can understand how someone's performing transactions. You can sort of normalize the behavior of that customer. Now, if you're trying to make a fraud detection system, it becomes super easy because you have real-time transactions coming in, and then you have this past 10, 15 years worth of data that shows what the normal behavior of a transaction is for each customer. If a new transaction comes in with the amount of $50,000 and you see for a customer that they've only made transactions under $100 in the last 10 years, that seems very suspicious. You can combine these two to supplement information and initiate a fraud detection model that triggers transactions to be flagged as fraud. So again, that was a very binary explanation of this use case. There's obviously nuances to where you want to flag a transaction, but then again, there's so many things you can do with it. Gaming is a use case that's very similar to retail because you have a lot of information about the customer, which in this case is a gamer. The key use case we've seen with Cosmos DB and Spark in this industry is monetization of games during the player's experience. You want to show them as relevant of a recommendation as you can using their past experience and the current operations that they're doing using their games. These are very standard cases. Now, this slide I find something very interesting about. Each of these use cases, each of these industries have a very niche market or a very niche use case. In healthcare, we're literally saving lives by giving consumers or hospitals the ability and infrastructure to trigger alerts based on past health patterns that we've observed among other patients, right? You've got all the patient data in the world, and as soon as someone else comes in and hooks up their vitals, their pulses, or their other health data, you can sort of see from past data when the last time, if someone was a cardiac arrest patient, that you see patterns that led up to that cardiac arrest, and you can sort of deduce that behavior or what triggers that sort of behavior using machine learning models that are implemented in Spark. And you can recreate that entire experience to trigger alerts to notify staff, like doctors and nurses, that something is going on here. You might want to check on this person. So it's literally like saving lives. On the manufacturing side, you have another very interesting use case. With the advent of sensors and IoT, you've got expensive machines, like drilling machines. If you're an oil and gas company, you're drilling with these expensive machines that cost thousands of dollars every minute to operate, right? If you start drilling for oil in the wrong direction and you're not aware of it, every second that you waste drilling in the wrong direction, you're wasting thousands of dollars. Now, think about sensors being attached to these drilling machines. If you could somehow leverage these sensors to provide you real-time feedback and you couple that with past data to sort of identify if you're going in the wrong direction, that really helps you out in saving costs because you can stop drilling right away and back off from that area, and you know you're not wasting your cost as well as effort. Logistics is another use case that is more of an umbrella. It covers a lot of industries as well. But the primary use case is a standard computer science problem. Think about Dijkstra's algorithm, just optimizing routes. You have to get from A to B, and you're trying to optimize your route. And a lot of things play into the variables in the air over here. Say you've got a plane or a ship or a truck on the street, and it could be the weather, the wind condition, it could be the traffic on the street that is really affecting your delivery from A to B. All these goods that are being shipped, right? And a large part of it is determined by real-time data, which is coming in through weather reports or whatever your source is. You can again use Spark and Cosmos DB in conjunction to optimize your routes and make informed decisions about your logistics route optimizations. And this is a very good use case that you'd see a lot of logistics companies use in the future as well. Now, I kind of mentioned that there's two main data processing architectures when it comes to real-time big data. Kappa is, again, something that is a very small bucket of what is used in the industry, because most of the times it ends up converting into Lambda architecture in the long run. That's because people realize that Kappa itself is not good enough to provide you a holistic view of the customer's journey and the impact that each transaction is making, which is why you need to couple it with long-term data and define the consumer behavior with batch views of their past historical transactions and the aggregations of their behavior as well. Now, typically, we're going to focus on Lambda architecture for this point, because Lambda, I think, covers aspects of Kappa as well as the bigger use case, which is Lambda. So let's look at how Lambda architecture has been implemented in the past and what is wrong with it and what is right with it. Typically, new data comes in, and then you've got to multicast that new data into 2 layers. There's 3 main components in any Lambda architecture. You've got the speed layer that takes care of the real-time data that's coming in. You've got the batch layer that has the master data set that helps you sort of create a pre-computed view that can be queried whenever you need to have like an optimized view of the entire data set. Your serving layer is nothing but the layer that holds that pre-computed view that can be queried whenever you need it. Now, typically what happens is Lambda architecture is really important because, like I said, you need the holistic view of everything. But there are a lot of limitations with Lambda architecture, some of them being, as someone who's implemented Lambda architecture in the early 2010s when Spark was new, the biggest challenge was for the serving layer, you notice that, or for the batch layer, let me start with that, because that's more of like closer to the actual initiation of the process. The batch layer needs to have something, a technology that is very robust and stable. Mostly, people ended up using Hadoop or HDFS back in the early 2010s for the batch layer, because that's where a lot of your master data set is. It's raw data that's just stored in the raw form, right? In your serving layer, people had, or in your speed layer, people had Apache Storm or Apache Spark, which are fast compute engines that can trigger real-time data and source it whenever you need it. In your serving layer, though, in the conventional architecture, back in the early 2010s, people had stuff like Apache HBase or any sort of faster lookup table database that can be used to have readily available data to be queried and coupled with your real-time data, right? Now, the challenges with having so many complex technologies in this one frame is that there's too many moving parts. It's not a managed end-to-end solution. It becomes really hard to manage this. It creates a lot of overhead. And that, for me and for a lot of other people that I've worked with, and the trends in the industry speak that this was a huge, huge blocker, and it was a huge developer concern. Now, how did we optimize this challenge of Lambda architecture in Cosmos DB? It's simple. We don't have to multicast anything to 2 different layers. We just use the change feed that I spoke of earlier. So you only have to source or ingest your data inside Cosmos DB. And since Cosmos DB has a feature called change feed, which is nothing but the backend commit log of events as they're coming in or data that's coming in, you can just use the change feed as a source for your speed layer. So you're only casting to 1 layer, which is the batch layer, and change feed takes care of the rest. You have to hook up your change feed with Spark to be able to source or stream this real-time data that's coming in, and your speed layer is ready, just like that. The batch layer and serving layer are quite similar to what they were like in the conventional Lambda architecture as well. This is pretty much the same thing. You've got a master data set that resides in the batch layer. Then you've got Spark that pre-computes a view and pushes that pre-computed view to the serving layer. And your serving layer is a faster lookup table or collection for your historical window of data. Say if you're a retail real-time analytics use case and you don't want to have 10 years worth of data in your pre-computed batch view, you just hold 1 year's worth of window, and then you can push that to the serving layer for faster lookups. And once that happens, your real-time view, as we discussed, was already ready. You can combine the views or the real-time computed view from your speed layer with the serving layer data, and that gives you a holistic view of what's happened in the past and what's happening right now. And you can make informed decisions based on that here. You've got so many things that you could do. Now, let's summarize what's happening here. This is Lambda architecture re-architected after moving some parts. You've got the new data that's coming in. The single layer, the single component that it's interacting with is Cosmos DB. Using the change feed, your new real-time data is going into Spark, where it's computing a real-time view. And then your existing data is now pre-computed also using Spark and made available in the serving layer. Combining these 2 views, you can do so many things because you can combine the past patterns of your consumers, customers, what have you, and then you can couple that with your real-time data, which triggers a lot of the events, right? Now, one thing I do want to clarify about Cosmos DB, back to the basics once again. I said that it's a NoSQL database on the cloud. When I say Cosmos DB is a NoSQL database, it's not a no structured query language database. That's a misconception. When I say Cosmos DB is NoSQL, it just means it's a not only SQL database. That's a misconception that a lot of people have, and something that we should clarify more often. What that basically means is you can have unstructured as well as structured data in Cosmos DB. We do not restrict people to any sort of data model, which is why we have so many multi-model APIs that you can leverage. Having said that, Cosmos DB offers a lot of benefits. Like I mentioned, global distribution, which we are going to talk about, and how Spark leverages global distribution in a very efficient manner. We're going to talk about that in a few. We're also going to talk about the low latency aspects and how that helps with real-time analytics use cases with Cosmos DB and Spark. Now, I don't want to be all about just architecture discussions, and we want to delve into the demos as well. So I'm going to hand over to my colleague Sri, and she's going to talk about a fraud detection system use case that we're going to start from scratch and implement, and you're going to see how it's done. It is super easy. So, Sri, over to you.
Hello, can everyone hear me back there? Okay, awesome. Thank you, Rohan. That was great. So as Rohan was saying, we have endless possibilities where you can leverage Cosmos DB with Spark. There are trillions of things you can do, endless possibilities. You can solve a bunch of data science problems. You can use Spark to do some fancy ML stuff. You can do complex aggregate queries, and so forth. So in the next few minutes, what I'm actually going to focus on is how you can do this. So as you've heard, we've announced some exciting new stuff. Now we inherently have Spark baked into Cosmos DB, and you will be hearing more about it from my colleague Ram. But even before this, moving back a few years, so we see an industry trend where the industry no longer wants to separate between OLTP and OLAP capabilities. They want a database which is which is super fast, which is super good for OLTP capabilities, but also should have the power or should have the capabilities to run aggregations or able to draw some meaningful business insights. And that's when we decided we're going to go ahead and build our own library or our own connector, which we call the Spark Cosmos DB connector. It's written in Java. It's an open source connector. So if you Google it, you'll be able to go and see our source code. So we've written this library about 2 years ago. And before I jump in and show you the demo, what I aim to do is how you can use the Cosmos DB Spark connector to do the two basic flavors of processing that are batch reads and batch writes and stream reads and stream writes. So how does the Cosmos DB Spark connector work? So first of all, the connector gives you the ability to position Cosmos DB either as the source or the sink of your Spark jobs. And wherever you're running Spark, this could be Databricks, HD Insight, or wherever it is, you first go and install the Cosmos DB connector libraries. This you can do either through the Maven coordinates or by downloading the Uber jar. I'll show you how to do that as well. So once you have the connector installed, next what you do is you specify the read or the write config. So pretty much you're telling which Cosmos DB container am I connecting to. And once you have the config in place, what we do is we establish a connection from the Spark master node to your Cosmos DB gateway node. So when this connection is established, what essentially happens is the Cosmos DB passes back the partition key or the partition map of the data. So now once you have this partition map, at this point, we can actually parse our Spark query to see what is the data I need to answer this query. And since we have the partition map, now we push down this information to our worker nodes so that the worker nodes can directly talk to the Cosmos DB data nodes. So as you know, Spark is a highly parallel distributed system. And Cosmos DB is a horizontally distributed database. So now when you have these worker nodes talking to these different data nodes, obviously your processing is going to be much faster. Okay, for today's demo, Rohan spoke about a lot of industry scenarios and verticals where this is being used. So for this particular scenario, let's take finance as an example. So in finance, we have a number of e-commerce sites. E-commerce is on the rise. I think I've stopped even going to a grocery store. Now you have fresh and tons of other stuff. So main problem with online transactions is online fraud. This could be credit card imposters, stealing of credentials, a lot of bunch of stuff. So today's scenario, let's assume we have a certain bank called Woodgrove Bank, and they're trying to do online payment processing systems. So their customers, end users are merchants. This could be any online site like H&M.com, Express.com, whatever you want. So they have customers or merchants all around the world. And what they aim to do is they want to provide a real-time fraud detection system to block fraudulent transactions as and when they come in. So for example, you have a customer who's trying to make an online purchase, and this system aims to detect if this transaction is fraudulent or not by using some advanced analytics and some machine learning models. So how do you go about creating such system? So we have a few requirements. Just to point out, I did say Woodgrove Bank has customers all around the world. So some of the requirements are the fraud detection system needs to be highly responsive. That means you should be able to distribute your data as closely as possible to wherever your users are. So that, I'm sure that gives you an idea. Like you know, Cosmos DB supports turnkey global distribution. That means once you have your transactions or once you land your data in Cosmos DB, it can be seamlessly replicated to users throughout the world. So that would make Cosmos DB a great fit as an ingest store. So before I do the example, I'm going to walk you through the quick architecture of how this would look for an fraud detection solution. So you have your payment transactions or your streaming events that come in. We're going to land all these events into Cosmos DB, or this is going to be your streaming ingest store. And as the transactions keep coming in, you heard some information about the change feed. So we have a feature called change feed, which allows you to stream events or stream updates as and when they happen. So using the change feed and structured Spark streaming, now you can land all these transactions into Spark. So now that you have these real-time events landing in Spark, you can do several stuff. So the first requirement is we should be able to block these transactions in real time. And the way Woodgrove Bank did this is they had some historical transactions or some clean data which they had in a CSV file, which they used to train a model. So they trained a model and they deployed this model in Spark. They use Spark ML or Azure ML. You can use different ML services in Spark. They trained a model, and now they've deployed these models. As these new transactions come in, we score these transactions, or we do real-time scoring against this pre-trained model to detect if this is fraudulent or not. Based on if this is fraudulent or not fraudulent, or how high the score is, we can hook into other microservices or web APIs to be like, hey, block this transaction, or report it to the merchant as a suspicious transaction, or take further actions. So this is the real-time aspect of it. But as you know, as the transactions keep coming, or over years, you have more new sets of data, and you cannot use the same old model you've used. So you have the requirement to retrain this model. Or even in certain times, for example, I was in Australia a few months ago, and the merchant blocked my transaction. I was like, hey, we see some new transaction coming in from across the world. It might not be you, so it was flagged as suspicious, but it was not necessarily a suspicious transaction. So this also means you will have some feedback coming in from the merchants or the bank itself on the credibility of the model prediction. So once you have this feedback in there, the Woodgrove Bank will schedule some offline batch processing to do several things. So the first thing is to retrain the model depending on the feedback and depending on the new transactions that came in. And the second one is to build materialized views. So now we have different types of transactions that come in, and the Woodgrove Bank wants to provide nice aggregated views to the merchant, like, hey, by the way, you have the most number of transactions coming from country Z, or you have this particular customer who had this many transactions over a period of 1 year. This is your top customer. Or to do further analysis, we can build nice materialized views where the merchant can directly go build dashboards on top of or build reports on top of in a nice, fast, real-time manner. So now let's take a demo of how this system is implemented. Okay, to start off with, the first question is, where do I get my Spark connector? So there are two ways to do this. If you're using Databricks or HD inside, you can directly point it to the Maven coordinates. But we did hear a few issues where Spark streaming writes did not work. So till we get that issue fixed, we highly recommend that you download the Uber jar. I've also included the links to all of this in my presentation, so you will be able to find it. So once you download this, for the purposes of my demo, I'm using Databricks. So in Databricks, you create your cluster specifying how much memory you need, so on and so forth. So once you've created that, you have an option to install libraries. So here I have both of them installed using the jars and the Maven coordinates. So I can say install new, and then I say upload a jar, and once whatever jar I have downloaded, I'll just drag and drop it. That's easy as that. So once you install the connector, this is a fun part. So that was going through the basics. So I'm going to show you two things, how to do stream reads and stream writes, and how to do batch reads and batch writes. So here I have a notebook open, and one second. Yep, okay. So there you go. So what you see here, or what I want you to pay attention to, is the read config. So it's just a few lines of code, and essentially what I'm specifying here is the first point. Which Cosmos DB connector do I connect to? So these are your endpoints and master keys. I used the Azure Key Vault to store my secrets, but if not, you can also directly paste your URI and endpoint, but I highly don't recommend it. And then you specify your database and collection. And then the interesting thing to pay attention to here is read change feed is true. That means you're enabling streaming and you want to read off the change feed. The other things you need to pay attention to is the change feed checkpoint location and the change feed query name. So these are the locations on your Databricks file system on where we are storing the checkpointing logic, or example, if your job fails, where do you continue to read, or what is your change feed checkpoints. So once you have the read config, you're going to open or you're going to start a read stream, which is the next command. So all I'm saying is start a Spark read stream and specify. Also, another interesting thing I would like to point out is in the format. You see that we're using Spark streaming. So this format differs for batch reads, stream reads and stream writes, and batch reads and batch writes. So you need to specify spark.streaming for that to work. And then you have options. You specify, you're saying use the config you just provided above. And for the purposes of this demo, I'm just writing the output of this to a memory sink, but you can write it to anywhere. You can write it to Delta tables. You can write it back to a different Cosmos DB account if you did some cleaning or if you did some sliding window aggregates or whatever you want. So stepping back 1 second, I'm just going to show you how my sample data in Cosmos DB looks. It decided to refresh. Okay, so in the meantime, what I have here is I have an offline or locally I'm running a transaction generator, which is simulating some of transaction data for me. So I have this running right now. I'll give it a few minutes to start up. So previously when I ran this, I'm just going to show you what some of my documents look like. So here, okay, let me. Okay, so I'm sorry, that's taking time, but so basically if you can see the right corner, that's a sample document. I have different information like country code, the transaction ID, the transaction amount, the payment billing postal code, just to give you an example of a document. And now what I did here is I've started my transaction generator, which is emitting some streaming documents, which will be inserted to my Cosmos DB account here. And now when I run, now what I'm going to do is I'm going to run my read config, or I'm going to run this change feed to read off our change feed, and you will be able to, we can see that as we're reading off the change feed, we can see at what process we're reading in the documents and we're processing these documents. You can see that the Spark jobs are running. So like you see, you can see my transactions coming in, the input versus the processing rate. So this I'm writing to an output sync. So let's say once now you have your transactions in Databricks, in Spark. So what you can do now, so you're going to load your data, or you're going to load your ML model from the pre-trained ML model from the Databricks file system, and you can now score these transactions as they come in, saying whether they're fraudulent or not. I'm not going to go into more detail, but for the examples of this demo, we used we used a model which we pre-trained using Spark ML and some scikit libraries. And after we score the transactions for whatever purposes, if you want to write it back, you could write it back to a different Cosmos DB collection. And this is an example of how the write config would look to write your streaming jobs back to Cosmos DB. So if you, the thing to pay attention to is in the format, for the write format, you will have to provide Cosmos DB sync provider, whereas in read, you say Cosmos DB source provider. These are sort of like tiny things I'm pointing out, but I've kind of broken my head sometimes trying to get it to work when I miss some small mistakes in the commands. But these are simple lines of code, and this is about it for the stream stuff. So moving on to batch. So what I have here, so now you covered the real-time scoring part. So now you have all these transactions in Cosmos DB, and you want to read these transactions from Cosmos DB to retrain your model, or to do some aggregations and write it back into a materialized view. So this is how a read config would look like for your batch jobs. You still specify the endpoints and the master keys and all of that stuff. So one interesting thing I want to point out is the query custom. So why do you want to specify this? So like we were talking about, probably would like to schedule your batch jobs to say run once every 24 hours or once a day, which will read in all the new transactions. So here I filtered on collection type transaction, but you could also filter by date timestamps to read in only the most recent transactions you need. So this is really helpful. For example, you have 2 terabytes of data in Cosmos DB. Necessarily, you wouldn't want to pull out all 2 terabytes of data in memory in Spark. So this is where the connector really helps in pushing down the predicates, or will push down your filters all the way to the Cosmos DB query engine, and then you only pull back the data you actually need. So once you've established your read config, what I'm doing here is I'm just cleaning some columns or removing some columns just to show you how the transaction data would look like. So if I were to run this, some of the data in here is you have the transaction ID, you have the postal code, is the user registered, some of the other stuff. So now that you have your batch transactions, or you're reading your batch transactions into Spark and Databricks, so the next thing is, what are some of the aggregations I could do? So in such type of data, some useful things you could do is, hey, aggregate all the transactions coming by country code and give me the average transaction amount. So this is just a sample query. So once I have this in here, what I'm going to do is I'm going to write it back to Cosmos DB. So for writing back, again, the write config looks something similar. You specify the endpoint and the master key, and the collection you want to write back. So I have something called the materialized view, and then you also specify the partition key, or the definition of your partition key. So another interesting thing to specify, to pay attention to here is the materialized view write format. So like I was pointing out, for streaming, you will have to specify that it's cosmosdb.streaming, whereas here you just say connect, the format is Microsoft Azure Cosmos DB-Spark, and you also have to specify modes. You have different modes like overwrite, append, upsert, and so forth. And that's the basic idea. Now let's try, so these are the results from what I had before. I'll quickly try and run it for you to give you an idea of how this works, but that's pretty much the explanation. So you have the read config. Now what I'm doing is I'm doing some basic cleaning of the data, or I'm doing some batch transactions, creating a temp table to work with this data to do some aggregates and create a materialized view. So like you can see, so this pretty much works. So just because we're short on time, I'm going to wrap up there. This is the idea. So I hope you understood what are the different cases you would use streaming versus batch and the different configs. So all of this will also be available in the slide deck. The crux of it is pretty much the few lines of code you need to establish the connections for stream reads, stream writes, batch reads, and batch writes, and whatever you do in Databricks is pretty much same as you would work. With that, I will give it over to Ram, who will talk about Coca Cola, who's been using the Cosmos DB Spark connector for several years, for a few months now for one of their projects, and he'll also talk about the new Spark API. Thank you.
Thanks, Sri. Hello, everyone. Ram here from the Cosmos DB engineering group as well. And hope you've been having an amazing build this year. So particularly on this topic, right, and the topic of real-time analytics and analytics on top of Cosmos DB is something which is very near and dear to me, because a couple of years back, I was one of the folks who started building out the Cosmos DB Spark connector, which Sri was talking about. And today, I'm helping design and build the operational, integrated operational analytics support within Cosmos DB. And we're really excited to announce the preview support at build, and excited to see how we can work with you to understand your Spark scenarios and really introduce this new paradigm of globally distributed operational analytics, which is very unique to something which we're offering today because of the capability of Cosmos DB to globally distributed data. So my immediate team in Cosmos DB engineering is responsible for leading the technical customer engagements for the service. And with that, we have interfaced with customers, enterprise customers in Azure at different stages of this data modernization, which we call it, right? This is a bit of a buzzword, but really, if you think about it, it's all of these enterprises coming back to redesign some of the core principles around how they store data. And this is all operational data, which is today growing into terabytes and petabyte scale. And this is how they store it in a globally distributed fashion, and also be able to derive insights out of that data. And that's the real key today, right? Which is, with all the Cosmos DB sessions you've been attending today, you will be able to understand how you can achieve OLTP scenarios in a global distributed setting. But right now, let's focus a little more on how you can derive insights out of terabytes of the transactional data. So, and I think a perfect example would be Coke. Let's just take a look at a video from the CIO and the execs at Coke, where they talk about how they about their whole journey on Azure, as well as which is centered around Cosmos DB.
Coke as a brand, it's about inspiration that brings people together. It's uplifting and it's optimistic. We're in over 200 countries. As a system, we employ over 770,000 people. We have brand partners that we work with, and we have over 1.9 billion serves of our products a day. Across our system, we have sales revenue, multiple currencies, multiple countries from multiple sources. And our challenge has always been to get insights up to speed. We're fully in with the move to cloud. The core part of that move is Cosmos DB.
Being a globally distributed company, we have petabytes of data that continues to grow. We wanted to partner with somebody who has a battle-tested infrastructure as we're running mission-critical applications. That's what, quite frankly, led us to Microsoft. We are collecting revenue as well as volume data from all of our bottling ecosystem and putting it in one place that allows us to draw insights. Being able to scale and have insights that are actually delivered within minutes is very, very important for us. We're very, very excited about Cosmos DB and the upcoming native Spark support, as well as operational analytics that are built on top of that.
The NSR program's brought our system together as we bring data from our franchise partners and the company together to better segment and better serve the needs of our consumer. It's delivered against that. It's delivered us the Cosmos DB technology that allows us to scale massively, and it's delivered against all of the time requirements we had about getting insight to market at the pace the market moves. I mean, this is the time that we can make a fundamental difference to our business, and I don't think it gets any better than that.
So that is a really, really satisfying video, personally, because I can very distinctly remember the day over a year back when we walked into the office headquarters at Coca Cola to kind of propose the solution we wanted to build around Cosmos DB and their entire Azure for this particular project, which is called NSR. So we looked at the video, right? Let's look at some of the key highlights here and what are the scale challenges here, which is Coca Cola as a company and all of the data which it generates as well it consumes is spread across 200 countries, and they serve over 2 billion products in a single day. So you can imagine every single product sale is going to generate an order of magnitude larger volume of records itself. So that's basically, this is the volume of data which they have to process within a single day. And so this NSR project within Coca-Cola is basically Coca-Cola is a franchisee business at the end of the day, which means they interact with bottlers across the world who basically upload data every day about the sales volume and sales revenue data on a specific day. So, and these bottlers are now spread all across the world. So they came to us asking for, can you propose to us a globally distributed common data store where I can store data not just from these bottlers, but also data coming in from internal business units as well as other third-party public data sources into a common data store, which has all of operational data. So this is not just a data lake which you can just house the data. This has to be data which has transactional requirements, and then be able to also derive insights out of that in near real time. And that was not enough, because this common data store, they wanted to future-proof it, which is today they have batch data coming in from all of these bottlers, but going forward they need to be able to ingest IoT stream data coming from point-of-sales machines as well as vending machines. So this is a common data store which has to scale at this volume as well as global distribution needs, and also be able to scale to both batch as well as streaming scenarios. So this is a very nice slide. You might have to squint a bit, but this was one of the slides which one of the execs had presented, and it really caught my attention because this shows not just about Coke, but literally every company and enterprise customer who wants to collect data, operational data, not just at the source of the data, but also all the way from, if it's a B2B business or a B2C business, right from the place where you manufacture data to through your logistics to your point of sales, that you can now segment this data and derive insights out of your business as well as understand your customer better. So that's really, this is a very neat slide which captures the essence of why we built this native operational analytics support as well. So no marks for guessing it right, but Cosmos DB was basically this common globally distributed data which has to serve both transactional requirements as well as warm analytics requirements. So I'm not going to spend too much time on the other aspects as to why Cosmos DB was chosen. It's very clear because 200 countries, so it has to have turnkey global distribution. Your bottlers are going to start loading files at any point in day, so you do not want to, an IaaS system where you had to provision for peak workloads means you have a higher cost of ownership, versus now with Cosmos DB you have elastic scalability, and you have SLA-backed latency guarantees as well if you want to build a web app which interacts with this data, both point lookups or point writes, right? But in this particular thing, in this next few minutes, what we want to look at is the fast time to insights aspect, right? So this is, again, a very simplified architecture around what Coca-Cola does. This is their main scenario when a bottler drops files every day around how much volume sales and volume revenue they had. So the data basically lands in blob very simple. But then this seems like a very simple ETL mechanism where they just have to do ETL from blob into Cosmos DB. So what's really big about it? The reason why Spark is in this picture is because it's not just ETL, but they have to do a lot of warm analytics as well as complex aggregations and joins when they have to move data from blob to Cosmos DB. This is because the bottlers drop transaction data, but you have to perform very complex joins against reference data as well as master data, which is stored in other collections in Cosmos DB. You need to be able to do data schema validation, data wrangling. So Spark as an aggregation framework is just very neatly positioned to be able to achieve this. So once you land data in Cosmos DB, you then, through the native AAS, Azure Analysis Services connector for Cosmos DB, we do a partial refresh of cubes they build in Azure Analysis Services, which then powered by Power BI dashboards as well as ad hoc Excel analysis. So one thing to note here is, again, that Informatica here is the orchestrator of the whole platform. And this is one scenario, right, where you're ingesting data. But that is essentially one, which is bottler file upload. But two is bottlers later need to come in to be able to run warm analytics as well as run reports on top of the data they've uploaded. And they just don't want to look at their data, but they want to look at data which other bottlers in their region or other regions have also uploaded. This is where Spark SQL, with all of its complex aggregations and join capabilities, really helps there. And then comes in, this is more of an operational scenario, right? An analytics scenario. But you also have regular transactional scenarios, which if you had a relational database or just a transactional database, you might just want a web app to do point lookups or do SQL queries on top of the data. You don't need to add the latency of Spark in there. So that is also another capability where you can directly hit Cosmos DB. And finally, from the cubes which power the dashboards, you have business analysts who view the data, right? So this, again, you might just want to squint a little bit, but if you see there are two parts here. There are circles which represent Azure, the location of Azure regions today. We have 54 plus regions today. And if you see the Coca Cola symbol, those represent the regions where there are Coca Cola business units. So what's really neat here is wherever there is a business unit which Coca Cola has, there is either an Azure region right in the same province or within 1,000-mile radius around the business unit. So, and the cool thing is Cosmos DB is a ring zero service, which means Cosmos DB is present wherever any Azure region is. So this has helped build a globally distributed NSR deployment, because whatever we saw so far is a single region deployment. This is what happens when you're now deploying an operational platform which is globally distributed. And there are two parts here, right? If you see in any one of those squares, there's a data tier and then there's a compute tier. So Cosmos DB being globally distributed, all you have to do here is create one single Cosmos DB account and add additional regions whenever you need to scale out your database to another region. But the same cannot be naturally said for the compute tier, right? Which is, right, let's focus purely on the analytics piece here, which is if you're running Spark, you cannot guarantee an RTO of 0, recovery time objective of 0, because Cosmos DB, if a single region goes down, we do an automatic failover to another region. But how do you do that for a compute tier? That is, if my East US went down, how do I take my analytics stack from there and automatically replicate failover to another region? And what about how do I place it inside the same VNet and all of these? So this is the core reason why Coca Cola and a few other customers really pushed us hard to go and build out the native support for Spark. So this is what the solution would now move to in future for NSR, as well as what we are proposing for everyone out here to if you want to build a globally distributed analytics setup, right? Which is you now have Spark. Once you set up Spark API on top of any other data API in Cosmos DB, you now have Spark jobs which are, you have Spark jobs which can now run in all of your Azure regions which are associated with a Cosmos DB database account. And now with Cosmos DB's multi-master capability, each of the regions is now a read and a write replica, which means your Spark jobs can perform both queries, reads, writes, all from the nearest region. So this way now, if Coca-Cola tomorrow needs to onboard another business unit onto this NSR platform, all they have to do is add another Cosmos DB region. And the data will be replicated, and all the compute analytics stack is also replicated natively there. So this is why we've built in native support for Spark and Jupyter notebooks right into Cosmos DB, which works seamlessly with all of our data APIs. So works with Cassandra API, Mongo API, the SQL API, all of them. So let's look at typically what the stack would a data engineer and an ML engineer would work with, right? So hopefully at the end of this talk, it's very clear to you that Cosmos DB is one of the top contenders for the database platform if you want to build a transactional / operational analytics system together. So that piece, let's leave it out. But as of yesterday, before we announced the Spark integrated Spark support, the entire top part, which is the choice of the compute platform as Spark, as well as Jupyter Notebooks, which is typically the most preferred ecosystem for running visualizations, as well as a collaborative environment where you can pull in a rich set of plugins and extensions to do visualizations. So that's a given. And that's the reason why we are going to adopt these open source technologies without rebuilding Spark, without rebuilding Jupyter Notebooks. We want you to bring existing Jupyter Notebooks, bring your existing Jupyter Spark notebooks, Spark jobs, and run them natively within Cosmos DB. So, and always, we can never talk about Cosmos DB in isolation, right? You will always, whether you're using Spark to do ETL, streaming ETL, you would want to connect to Kafka, event hubs. Or if you want to connect to other data sources as well, MongoDB, Cassandra from somewhere, you need to be able to connect to those data sources, right? And so that's what, as you onboard with the Cosmos DB Spark API, you'll see that all of these connectors come inbuilt with the runtime, where we want to eliminate the requirement from you to go add these connectors, go around and fix the class paths and all of that. So we want to solve that problem, as well as with the data science and ML packages, scikit-learn, Azure Machine Learning Service libraries, NumPy, MML Spark, Plotly. Basically, all of the data science ecosystem comes in as packaged in the runtime. So if there are additional requirements, you can always add additional jars to the runtime. But otherwise, all of this comes as a native stack. So what we now say is the red line is removed, and the entire stack of Jupyter Notebooks as well as Spark comes built in to Cosmos DB. So I would love to go into detail as to how we are building this out. There are significant, a lot of design choices we have performed in not running Spark on Jupyter Notebooks on VMs, like how you would run a Spark cluster right now, because there's a lot of resource governance and resource utilization which we are able to improve on by running these Jupyter Notebooks and Spark master and worker nodes as containers. So that's the real cool thing we're doing right now, which is running all of these as containers within the compute infrastructure of Cosmos DB, which you will see now, which is how we'll be, both from a TCO, total cost of, as well as from a resource utilization point of view, is significantly better than compared to the existing choices you have when you have to run it. Even if you say, apart from all of the global distribution and the RTO 0 capabilities, which the integrated Spark experience gives you. So we might be running a little short of time, but if you'd love to stay on, I'd just like to show you a very cool demo, which we have now put together with cognitive services teams, because with this compute infrastructure coming directly within Cosmos DB, this now allows us to not just run Spark, but allows us to build native integrations with Azure Machine Learning Service, cognitive services, so that you can now run cognitive pipelines natively within Cosmos DB. So I'll show you a very cool demo. I'm not sure if many of you were there. We showcased this demo at the cognitive services session yesterday as well, but I'd love to walk you through this. This is a real life scenario. So just a quick thing before we get into the Jupyter Lab notebook. So once you sign up for the preview and we start onboarding customers onto the Spark API, all you would have, this is how you would look at it. So you can choose any of the existing data APIs along with the Spark API. And once you do that, you can now replicate once you add any region, you can now see that it combines both the data API as well as the analytics API in each of the regions. So both are co-located in each of the regions. So what we're going to look at today is Hendrik Motorsports. Oh, I didn't realize I was not presenting. Yeah. So OK. So Hendrix Motorsports is actually one of Azure customers. They are a racing team in NASCAR. I'm not a huge NASCAR fan, but I'm sure a lot of you are, and you might relate to this. So Texas 500 is one of the apparently really cool NASCAR races. And this is what we did is we worked with Hendricks Motorsports to actually get the race telemetry from the Texas 500 race. So this is over 30 race car data, and each of them at over 5 hertz is sending data at over 5 hertz. And let's take a look at what that data looks like, right? So this is the actual data, and you can see it's very rich. There are telemetry coming from each of the cars, which shows you the latitude, longitude, what's the RPM, what's the brake, where is it heading, and a lot of other cool things. So this is where Cosmos DB can scale to ingest all of this data. But where does the analytics piece come in, right? So apart from telemetry, we also have a couple of other sources of data in Cosmos DB. One is the data about the player profile, as well as audio data. So this is where the audio data itself is stored in blob, but Cosmos DB is an index to the blob. You have documents which we can now look up as to know which exact location I can go pick up my audio file for a specific driver at a particular point in time. So now that we have all of this data, this is actually as simple as this gets, right? So this is actually the UI which you will see as you onboard onto the Spark API, which is the Jupyter Notebooks comes built in to the data explorer of Cosmos DB. So you can now explore your data, but you also can write notebooks and explore all of these notebooks in real time. And you can collaborate with more people, and this is how we want more people to collaborate on top of the data. So as Shri just showed you, you can, with a single line of code, you can now read data and apply filters to read data from Cosmos DB into Spark, right? So the core thing is visualization, right? A lot of times I've had this issue where when we work with customers, we load the data into Cosmos DB, but it's not enough if I just run min-max queries to visualize the data, right? Sometimes you really need some rich visualizations to see what that data means. So here, because of all of the native we're not building anything new here, which is we're just using Plotly, which is a rich extension in Jupyter Labs for visualizations. So here I'm just basically taking the first couple of minutes of the race, and I'm basically looking at the data for the top 5 races. So you can now look at this is basically the first 10 minutes of the players and their relative positions. And then comes in track strategy, right? Now I want to basically look at I want to embed this data on a real map and see where are racers accelerating and where are they braking. What is a cool way to do that? This is all the code which I had to write, but with that, you can now look at this, which is the green represents where people apply throttles, and the red represents where people apply brakes, which is nothing extremely new here, but you can see that the hairpin bends that people brake more compared to the straight stretches where they accelerate. Then comes in more native Spark support, right? I want to load the race telemetry about drivers and actually analyze how drivers are performing. So this is where Spark's aggregation framework, there's group by and all of its aggregation capabilities with joins comes in. But now I have the option to visualize that very neatly interactively. So here I'm just looking at what is the percentage of time every driver spends in acceleration versus brake. So it's very clear that the more experienced drivers spend less time braking, and they can actually push for more time where they throttle. All of this is just an example of like how you can now very richly visualize your data here, right? So one of the cool things, as I was saying, what we are working on, and you'll see in the coming announcements as well, is we're working with cognitive services, AML, for native integrations with Cosmos DB. So you can store data in Cosmos DB and enrich your data with cognitive service pipelines so that you don't have to write much code to move your data out of Cosmos DB to kind of understand and enrich that data. So MML Spark is basically is a very well-written Spark package which combines a lot of cognitive services natively within Spark. So here we actually showcase an anomaly. So anomaly detection was a cognitive service which was announced recently. So here what we show is, can I apply anomaly detection on the RPM data, which I have from my race car telemetry? So here we apply univariate anomaly detection on top of the RPM data. And let's look at, it just takes a couple of seconds for run the anomaly detection. So, and then let's look at what the anomalies look like, right? So it's a nice graph here, but let's look at some portions of this. So here, this is RPM, right? So if you see the yellow and the red and the green line, that actually represents, in NASCAR, you actually have a lot of crashes, more than an average 5 or 6 per race. So the yellow represents a point when the waving flag was raised, where the drivers cannot race amongst themselves, but they have to maintain relative position, which is why you can see a significant drop in the RPM. And that's actually what anomaly detection just suggested out as well. But there's some other nice parts, which is, if you look at the last part, right? So what is this? So here I see again that the yellow line represents that a waving flag was raised, but after that the RPM basically went down to 0. What does this mean? So what we did is we actually found the video of this exact race. And if you just look at it, it's very clear, right?
He chooses the inside line again. The 12 car, Blaney has some experience with that outside line. Yeah, that was close. Front
Yes,
damage
that's
from that.
why it happened. So that particular car, which we were looking at, we were basically doing anomaly detection for, was the one which actually crashed into the sidewalk there.
Well, that's only 2 cars now.
So
one
no
lap
guess is,
down, and
no,
one
I
of
mean,
those
it's not
being
surprising
Kyle
why the
Busch.
RPM now went to 0. But this is now a cool thing where you can now very richly analyze your data natively within Cosmos DB, and then kind of understand the semantics out of it by either including your domain knowledge or going and doing any external research outside. One more really cool part, because we just didn't want to do one cognitive service, we said, OK, let's show speech to text. So what we did is, I said we also got the audio data from the drivers during the race, right? So we store that in Cosmos DB. What we do is we pass it through a speech to text a cognitive service here. And what we do then is we basically get tags out of that, right? And what you can then do is now enrich your telemetry data with potentially keywords which you think are flags. Like, for instance, in this particular scenario, what you could do is if the driver is essentially experiencing some sort of discomfort, when he says something like that, you can now build pipelines, alerting pipelines on top of that to say, when do you need to pit stop? So it's essentially a predictive maintenance kind of architecture. So this is more of the coolness of the speech-to-text capability of cognitive service. So you can see that the audio which I'm going to play is a little muffled, but it's actually able to, the text is what the speech-to-text detected. You can see that it's actually
I'm ready to go here if you are. Yeah, the 11, he was right on the bottom. I'm ready to go here.
So you can see that it's actually able to very clearly capture what the text was. And this is the cool capabilities of which MSR and a lot of our Azure AI folks are doing. And we want to be able to, for you to operationalize this, and which is why we are bringing that natively into the place where you're storing your data. So the last part which I wanted to say was, this is good, but what you want to operationalize this. This is where what you would want to do is define a pipeline, where you would define a pipeline of taking this data, applying anomaly detection, running it through the speech-to-text as well, and storing it back into Cosmos DB. So this is how you would do that, where you will define a pipeline out of these multiple stages in Spark. And this is the cool thing about Spark, where you can define such pipelines and then very easily turn your batch layer code into streaming layer code. So here I'm setting up this streaming job, and you see it has started because it says processing new data. And so end-to-end, this is basically what the workflow looked like, where I store my data, race car telemetry data in Cosmos DB, apply a bunch of aggregations on top of it using Spark, pass it through a bunch of cognitive service pipelines, and then enrich my data into Cosmos DB and another collection. Or you can just upsert your existing data. But all of this now just happened within Cosmos DB. It is the single data explorer where I did all of this. I never took my data outside Cosmos DB ever to do any of this. So that's really one cool thing which we wanted to showcase about what this now opens up as opportunities for people to do with the real-time data. So this is a pre-built AI model, but you now have the capability to go and build custom models as well, where you can. So if you see, I think it's a bad omen if any demo goes something going wrong. So yeah, so this is essentially how you can go out and build. You can use Spark ML to go build a custom model as well. So here this is another scenario where we take retail data. You can now fetch that data into Cosmos DB, split it into train and test, and here we apply a very simple logistic regression model to do a classification on whether or not, based on the context around a purchase, whether a person would actually purchase a specific product or not. So this is just another case of that you can now use pre-built AI models as well as custom AI models can be built within the Spark infrastructure of Cosmos DB. So I think this is kind of what we wanted to leave you with. And we really want you to go and sign up for the Spark API preview. We want to work with you to understand what your existing Spark usage is, and we'll work with you to onboard you and kind of help you on this paradigm shift to this globally distributed analytics and AI. So I think with that, I will leave you, and sorry for the extension. It's a 5 to 10 minute extension.